Hi everyone. So welcome back. Uh, so we have covered quickly, what we did, a quick rewind of AI, what is generative AI, how we work on it, what are the concepts, what are the terminologies used. So that's what we covered. Let's go to the next part where basically we look at it. So you can also refer to this YouTube channel of mine. So this is a playlist where you can find all the YouTube videos for these LLMs and GenAI workshop which we have done. Okay, I will go directly to the prompts which we were discussing. So understanding how do we interact with LLMs. Okay, flexibility and interaction on LLMs. So trained on text generation tasks such as predicting the next token in a sequence. So it's very important for you to understand how you give in a prompt because your answers are generated accordingly. Okay, filling a missing token in a sequence. So if you see here, let us offer our heartfelt apology for what we did last week entitled. Uh, we are filling in a missing token. Dear readers, let us offer our heartfelt apology for what we wrote last week in the article entitled. So this is something which we have filled using the sequence. Now, instruction following model. So these are some foundation ones. These are instruction following. So give me three ideas for cookie flavors. So it is given chocolate, matcha, peanut butter, etc. Write a short story on dog, hat, etc. So it's giving you a paragraph on the same. So foundation models and instruction following models. So these are the different LLMs which we are talking about. Prompts, so basically your inputs and queries. So prompt construction is very important, like using delimiters as we discussed. Use your delimiters effectively. Summarize how to give the data input. So if you see the code is also say in a similar format where you give the pipeline and you give the input like summarize a magnitude 6.7 etc. NLP, so natural language processing, which happens, code snippets are taken, combination of above is working on, and you get the results. Prompts get complicated also, so if you don't use them properly, it can get complicated. So these are some coming from the lang chain. So if you see from the last slide, so here we have just given the input, okay, and the pipeline. Now again here what we are doing is uh, extracting output using LangChain. So if you will see right now, like we have given the schema, then the output schema is kind of given. Now let's go to the another part of it where I show you the code. So we will show the code snippets as of now because we are not coding right now. But yes, coding is definitely needed if you want to perfection on what we are looking at. Prompt guide guides the model to complete tasks. So different models may require different prompts. So many guidelines released on what chat GPT input should be. They may not work on non-chat GPT models, etc. Good prompt usually is the instruction, context, input, output, etc. This is LangChain. It's okay. I'm just trying to show you the meaningful main tasks what we are doing. So LLMs have wide range of use cases. So if you see summarization, sentiment analysis, translation, zero shot classification, zero shot classification. So we did previously. You can always refer to the last video for these. Hugging Face provides many NLP components already. So we get data bifurcation list, filtering the tasks which we can do through this. Selecting a model based on task, model size, parameters, etc. Prompt engineering is basically then asking the question. Now, embedding vectors and search. So basically, how do you do that? How do language models learn knowledge? Through model training or fine tuning. So how do we do it? We do train our models based on what data we have. Then fine tuning is usually best suited to teach a model specialized tasks. So first you need to understand how to select a model, and then you need to come on the next. Analogy: studying for an exam 2 weeks away. Passing context as model input improves factual recall. Okay, so you need to basically understand how do you pass the context as a model input, because again the output is all dependent on what you're trying to give as an input. So 3.5 was actually a bit time taking, and obviously it has bound to be, because ChatGPT 5 is more efficient and has used better uh, versions. So definitely it's an improved version, so you can use that. Now this shows you how it divides it into vectors. What we do is we represent words, and then we, from to organization, we convert it to vectors. Now these are the vectors which gets converted. So n dimensional word vectors, if you see above, and things. And similarly the plot has been given in graphical representation for the same. Turn images and audios into vectors. So basically you have data objects, vectors, etc. So you can turn them into tasks later on and work on them. Use cases of vector databases basically that you can look in free time. It's something we have already discussed. Uh, Fine tuning your model and understanding and processing the model through RAG. That's basically retrieval augmentation generation. So the RAG models. This is a RAG workflow. If you see, nothing but basically your documentation. The data is there. You give it to language model. The language model basically converts your document into embeddings. It plots through vectors. Plots on the data. You're converted to vectors. This vector is going to vector database library, and in the backend basically user submits a query as well into language model. Now both of them interact at this point where you have vectors, and then your language query is coming in converted into again vector. So one vector versus two vectors comparison is here. Semantic similarity search compares, and then ultimately you get your generated output from here, and user gets the output from there. How does vector search work? So there are two algorithms, KNN and approximate ANN, basically approximate nearest neighbors. So these are two algorithms which help you find the nearest neighbor. By nearest neighbor they mean nearest similarity point. It will find the nearest data point in your data uh, to identify similarities between different data points. In the end it can perform and make clusters. So that's how. So if it identify patterns for specifically 5 trends, it will show you 5 clusters separately. Examples of indexing algorithms. So these are some indexing algorithms which you can use through this. Just remember, like Annoy, so that is by Spotify. So they in the backend, they are providing these as well. Clustering FAISS by Facebook. How to measure these two vectors? So Euclidean distance and L2 and L1 is used. Basically Euclidean and cosines and distance are used. L1 and L2 basically. If you see distant matrix, higher the matrix, less similar. Similarity matrix, higher the matrix, more similar. So there's a difference between similarity and distance matrix. So more the distance, similarity will be less definitely. Nearby, similarity will be. Compressing vectors with product quantization. So you look at your final vector. Facebook AI similarity search. Yeah, so these are things which we need to kind of navigate through. Hierarchical navigable small worlds, so builds, proximity graphs, etc. So these are the things which we need to look at again and understand. Uh, Filtering, how do you filter? The adding filtering function is hard. Okay, so how do you do it? You basically do it within the query when you're running it. So as you see, post query, in query, pre-query. So you can select your stage where to filter out the data. Post query filtering applies filters to top K results after user queries. So that is another one. And hash number of results is highly unpredictable. So these are some pros and cons which you're looking at. Maybe no products meet the requirements. That's another point. Yeah. Inquiry filtering. So compute both product similarity and filters simultaneously. So product similarity as vectors, branding as a scalar, leverages ANN speed. Okay. So basically computing both of them simultaneously is what we are trying to do here when we are putting it in the query, because it will run simultaneously when we are looking and processing the data. Pre-query is where you give beforehand. So search for products within a limited scope. So all data needs to be filtered, slows down search definitely. So what we prefer is, I think this one would be more preferred, frankly. And yeah, now this is a vector store. So what are vector databases? As we discussed, once they are converted into vectors, all the words basically are stored into one data set, which is the vector database. So that database is basically your main database where you can refer to everything. Specialized full-fledged databases for an unstructured data. Speed up query search for the closest vector. So this is the characteristic we are looking at for VDB. What about vector libraries or plugins? So what do you think would happen there? Anyway, so don't worry. What about vector libraries and plugins? So basically, vector libraries. So libraries create vector indices. If you see, ANN sufficient for small data processing, need to wait for full import. So these are some local challenges which you face. With plugins, it has architectural enhancements, relational databases, or search systems already in it. Less rich features, less use API, but it has relational DB, which is different from the other one. Do I need a vector database? Yes, definitely you need a vector database. Before that, you will not be able to identify similarities or patterns between them. First, popularly used vector database companies. So comparisons basically. So you can use these comparisons if you want to, go sometime go ahead and look at it. Best practices. Do I always need a vector store? Yes, you need it for summarization, text classification, translation, etc. You do need it. How to improve retrieval performance? Very important. Embedding model selection. Do I have the right embedding model for my data? Do my embeds capture both my documents and queries? So it's very important to check on these queries and questions before you select a model. Document storage. So you can store it as one or in chunks. Choose your embedding model wisely, because your embedding model will decide your outputs, how your model will be trained, how your output will be generated, etc. etc. Ensure the embedding space is the same for both queries and documents. Chunking strategy. Should I split my docs? You can if you want to. Otherwise, it's okay. You can process it accordingly together. Chunking is use case specific. So if there is a lot of data generally, you try to divide it into chunks and try to embed it differently. So we know user behavior, how long are the queries? Long queries may have embeddings more aligned with chunks returned. Short queries can be more precise. Chunking best practices are not yet well defined. Existing resources, text splitters by lag chain, blogspot on semantic search, etc. So these are some things we are looking at. This is just a summary of what we just read. Vector stores are useful when you look at context augmentation. Calculating vector similarities or distances is what vector search is. Vector database we already went through. Select the right embeddings for your model. Then the chunking strategy or document splitting strategy. That's all we covered in here, right? Now we look at some multi-stage reasoning. Okay. What is multi-stage reasoning? Describe flow of pipelines with tools like LLMs or LangChains. Apply LangChains to multiple LLM models, OpenAI, Hugging Face, etc. There are limitations when we are looking at single task. So what happens is, because it's too much of data in the back end, it's multiply, sending it to one classification technique. It slows down the process. Question answering becomes slower. But at the same time, if you do task single interaction with an LLM, it's more like a similar to something like batch processing, but the difference is that your prompts basically come from different documents and they align through one to give you multiple responses. So see, direct LLMs calls are just part of a full ask application workflow, etc. Summarize and sentiment. Example is multi LLM problem. Get the sentiment of many articles on a topic. Now, what is the issue? Can quickly overwhelm the model input length. Better solution is two-stage process to summarize and perform sentiment analysis. Prompt engineering, crafting more elaborate to get most of the interactions. So these are some examples, how we summarize. So you can do task summarization. So if you do like a summary, it will provide you a summary here through summarizing part. Then using a generalized template. So if you see last line, so that's basically a generalized template where you're trying to kind of use the model which you have created. So that's the template. We can create many prompt versions and feed them into it. So you can see like we did use the template, but now we have created an instance was nothing but a function where we are calling it again and again in the loop. So you can do that multiple times also at the same time. Now multiple LM interactions in a sequence. So again, what it is, chain prompt outputs as input to LLM. Okay, cool. So what do you understand by this? I can explain, but what do you understand by this? Anyone? So what we are saying is multiple LLM interactions. So you've extracted outputs from one model. Now you're giving that output as an input for the other model. Yeah. So see, what this we are going to chain the LLMs together. So what you see here, they have a summary from an LLM. That summary is basically combined here and given as a sentiment LLM, and overall sentiments are being chained. Multiple LLM interactions build complexity and functionality. So LangChain, one of them, released in 2022, used for multi-stage reasoning based workflows. But yes, at times it can confuse you when it's longer enough. Multi-stage LLM checks chains. So that's another one. You can build a sequential flow summarizing it, and similarly this is the workflow you are looking at, where it's processing an output and giving it as an input. Chains with non-LLM tools, how to make a LLM chain that evaluates mathematical question. So it's something where you kind of ask a mathematical question and it calculates and gives you back the answer. So that's kind of an evaluation which you're doing through it. So yeah, I think let's stop here. Uh, we will cover the agents later. So what we need to understand is, um, first topic we'll cover in the next video will be how do you select your model. So model selection will be the prime thing to check. How do you do it? And then thereafter we'll jump on to looking at, okay, how do we tune our model. So we will detail discuss the RAG implementation for fine tuning of models. That will be the two items which we do in the next session. And thereafter, once we are done and we are trying to understand how do we do, we'll build a code. I'll show you the code which model which we would have done using LLM chain models, and then we'll jump on to the next one, which is agent AI. So yeah, that's it from my end for this session. Let's connect for the next one. Thank you. Bye.